guys, this is the Maths Doctor and welcome to my YouTube channel. So today we're going to do a very interesting topic. We're just gonna do a question from a grade 12 question paper on differential calculus. So I want us to have a look at 9.2.3, right? So remember, this is differential calculus. We have d over dx, then in brackets 4 plus the square root of 3x all over x. So when you have an expression like this, the first thing that we are going to do is to try and arrange our fraction in a way whereby we can apply the rules of differential calculus. So this is what we're going to do. This is gonna be d over dx, right? Then in our brackets, we can say 4 plus square root of 3x over x. We can separate the numerators. How are we gonna do that? Okay, we're gonna start by saying 4 over x, like this, and then we say plus, then the other term in the numerator is the square root of 3x, right? Then we also put it over the same denominator, which is x. So you separate them like this. That's the first step. Okay, so now the next thing that we're going to do, I'll write equal to, so we have d over dx, right? So now that what we need to do, guys, if we have 4 over x, we need to try and take the x and bring it to the numerator with the 4, okay? So the x needs to go up and be on the same level in the numerator with the 4. So I'm gonna write 4. Then if I am to bring this x to the same level or to the numerator with 4, what's gonna happen to it? Okay, this is how we're going to do it. X, it has an invisible exponent of 1, okay, because they did not write any exponent on the x. So as long as you don't see any exponent that they wrote on the x, it means that it's 1. It's always like that, okay? It does not mean that there's no exponent. It just means that the exponent is 1. It's just that when it's 1, you want they don't have to write it. You just have to know, or if it's not written, it means it's 1. So if you want to bring this x to the same level with the 4 to the numerator, when you bring it to the same level with 4, the exponent of the x, which is 1, it will change in terms of the sign. So if it's positive 1 like this, when you bring it to the same level with 4, it becomes a negative 1. Okay, so whenever you are moving something in between numerator and denominator, all you have to do is to change the sign of the exponent. So if it was exponent positive 1, because you are taking it to the numerator, the exponent will change, the sign of the exponent will change, so it will go from positive 1 to negative 1. If you take it back to the denominator, it will change from negative x to exponent positive 1. So you just have to change the sign of the exponent. And then we say plus. On the other side, we do the same thing. We have the square root of 3. Okay, and another thing that is very important that we need to do. If we have the square root of 3x like this, we can separate it into the square root of 3 multiplied by the square root of x. So if it's 3x, I put 3 inside of its own square root, and I put the x inside of its own square root. So when I separate them like this, if it's the square root of 3x, I can say the square root of 3 times the square root of x, right? And then the x that is in the denominator, I'm gonna do the same thing and bring it to the numerator. And it also has an invisible exponent of 1. So if I am to bring it to the numerator, the exponent 1 will change to exponent negative 1. So it will be x exponent negative 1, like this, right? Then I close my brackets. Okay, then let's move on to the next step. So from here, this will be, okay, let me do this. Okay, here's my bracket here, right? So this will be equal to, let me just write it a little bit to the left. So this is gonna be d over dx, right? then in brackets, this is what we're going to do. We have 4x exponent negative 1, right? Then we're going to say plus, here we have the square root of 3, and then the square root of x, guys. You must try to keep x outside of the square root, or you must try to write x without the square root. How are we going to write the x without the square root? It's actually very simple. Okay, the x, it already has an invisible exponent of 1, like we said, because they did not write any exponent, right? So what you can do, you can write x, and then you write the exponent 1. And because this is a square root, it means we can just write, instead of putting the square root, we can just take exponent 1 and put it over the 2 from the root, like this. Okay, so that's another way to represent a square root. If you have a square root and you don't want to write the x inside of the square root, you can translate the square root to be in the form of an exponent by taking the exponent of x, which is 1, and dividing it by the 2 from the square root. Okay, if it's a square root, it means that we have a 2 there, but it's just that it's not written. So it's 1 over 2. Then we say multiplied by, okay, this is multiplied by, we still have x exponent negative 1, right? Then close brackets. Okay, then this will be equal to d over dx. Then we still have 4x exponent negative 1, right? And then plus the square root of 3. Then now, guys, since we have x and x like this and we are multiplying, to simplify things, we can just add the exponents. Okay, if you have the same base, when I say the same base, I'm talking about the x and the x. The base is the same because they are both x, right? So if you have x like this, is the same base, and then we are timesing them because the dot means multiplication. It means we can just add the exponents. We just say 1 over 2 plus negative 1. If you say 1 over 2, let me write it like this. Okay, so it's going to be x, then we add 1 over 2, the exponents, right, plus negative 1. So you write one base of x and then you add the exponents of the two bases because it's the same base. Okay, so if you say 1 plus negative 1, this should give you negative half. It's going to give you negative half. So you're going to have negative half, which is the answer for 1 over 2 plus negative 1. Okay, then now we're going to go into the step where we apply the power rule from the rules of differentiation. So this is going to be d over, okay, let me write it like this. Okay, now that we are applying the rules of differentiation, I don't have to write the d over dx anymore. I don't have to put it anymore because I'm now applying the rules of differentiation. How do we apply the rules of differentiation? You're gonna take the exponent, like negative 1 here, the exponent of the x, you times it by the coefficient of x, which is 4. So you say negative 1 times 4, which gives us negative 4, right? And then you write x, and then you are going to have to subtract 1 from the exponent. Immediately after multiplying the exponent negative 1 with the coefficient of x, which is 4, you are supposed to subtract 1 from that exponent. So you're going to have negative 4x, and then when we subtract 1 from negative 1, it will become negative 2. And then we say plus. Then next, we are going to take the exponent of x again from the other term, which is negative half, right? We're going to take the negative half and then we are going to multiply it by the square root of 3. So if you say negative half, you times it by the coefficient of x, right? So you say negative half times square root of 3. This is going to give us negative the square root of 3 over 2, like this. Okay, negative the square root of 3 over 2, and then we have to subtract 1 from negative half. Okay, so it's like negative half minus 1, or let me just say minus 2 over 2. 1 can be written as 2 over 2, right? So this is going to give us negative 3 over 2. That is the exponent. Then this will just be your answer. This will be your final answer. If you can also change the exponents to become positive, but you don't really have to. If your answer is like this, then this will be, you'll get full marks for writing the answer in this way. Then we are done. Simple and straightforward. Okay, I really hope you enjoyed the lesson. For more math sessions, what you can do, you can contact the number 081 703 1197 so that you can be able to get assistance with maths. Thank you so much.